Hello everyone, here is today's problem. We are given a triangle with side lengths 13, 14 and 15. With a point inside the triangle where the distance from the side is x, y and z respectively as shown in the diagram. So our task is to find the minimum value of x squared plus y squared plus z squared. We are going to use Cauchy inequality to solve this problem. But before that, let us find out what is the area of the triangle. In order to find the area of triangle, we need to find the s, which is half of the perimeter. So that is half of 13, 14 and 15. So this is actually 3 times 14. So this is 21. So we are going to use Aaron's formula, and this is square root of s minus a, s minus b, and s minus c. So that is square root of 21 times 8, 7, and 6. Note that 21 is 3 times 7, and 8 is 2 times 4, 7 is 7, and 6 is 2 times 3. We have square root of 3 square, 7 square, 2 square, and 4. So the answer will be 3, 7, 2, and 2. So the answer is 84. Next, we also can get the area triangle by adding a few lines here. So we can join the line in this way. The area of this smaller triangle, the area of the triangles is equal to half of 13x plus half of 14y and half of 15z. So with this, we know that the area triangle is equal to 84. So which means that 13x plus 14y plus 15z equals to 2 times 84, that is 168. Now we are going to use Cauchy inequality by considering 13 squared plus 14 squared plus 15 squared multiplied with x squared, y squared, and z squared. This will be greater than equals to 13x, 14y, and 15z whole thing squared. 13 squared is 169, 14 is 196, and this is 225. X squared, y squared, and z squared. And we know that this is 168 squared. This is 590. So x squared plus y squared plus z squared is at least 186 squared over 590, which is about 47.83. So equality holds if and only if 13 over x equals to 14 over y equals to 15 over z, which is achievable. Therefore, the minimum of x squared plus y squared plus z squared is equals to 186 squared over 590. That's all for today's lesson. Hope you enjoyed it. I'll see you again next time. Bye bye.